Good morning, friends. I hope all of you are doing well. Already, you have gone through the in-semester examination. I hope your result will be also good. Okay. Today we'll start the unit number 4, that is design of cylinder and pressure vessel. Okay. Already you know we are having total 6 units. Already 3 units we are completed in the classroom. The remaining units are 3. Okay. For the end semester examination, the unit number 5 and unit number 6 is most important because these two units contain near about 26 marks. Okay, so first we will start with the fourth unit, then fifth and sixth. The unit number 4 is, as I said, design of cylinder and pressure vessel. Unit number 5 is design of IC engine component, and unit number 6 is design of optimum design. Okay, in unit number 4, this unit is again divided into two types. The first one is design of cylinder and another is design of pressure vessel. Today we'll start with the design of cylinder point. Okay, in that we are going to see 3 to 4 points. The first point is what is meant by cylinder, what is its function, what are the different example of cylinder. After that we are going to see what are the different types of cylinder. The first one is thin cylinder and another is thick cylinder. After that we are going to see what are the different stresses in thin cylinder, what are the different stresses in thin spherical cylinder, so that we will cover in this unit. Okay, let's start with the first point, that is cylinder. Okay, maybe you are aware this word so many times, that is cylinder is nothing but what? It is a mechanical device used for storing, receiving, processing or carrying the fluid. Okay, and a cylinder may be a pressure vessel, storage vessel, hydraulic device, engine cylinder and pipe. Maybe in the IC engine subject you may heard about the engine cylinder term many times, so you already aware of this cylinder term, okay, from the first year to till date. Next point that we are going to see, this cylinder is classified into two types. The first one is the thin cylinder and another one is the thick cylinder. Okay, now here we are going to differentiate these two terms by using one simple formula or simple ratio, you can say. Okay, this ratio is nothing but what? Di divided by t. Here di is nothing but what? Inner diameter of cylinder and t is nothing but thickness. Okay, again I am repeating, di is nothing but what? Inner diameter of cylinder and t is nothing but the thickness. Okay, in that case, in thin cylinder there is a ratio of di by t which is greater than or equal to 20. Okay, and in thick cylinder this ratio is what? Di divided by t which is less than or equal to 20. What does that mean, di by t? Okay, in thin cylinder, if the ratio of the inner diameter of the cylinder to its wall thickness is greater than 20, then the cylinder is called as what? Thin cylinder. Okay, and the example of thin cylinder is, first is low pressure, boiler, storage tank and receiver. Okay, next type of cylinder is thick cylinder. Okay, in that case here the ratio is what? Di by t which is less than or equal to 20. It means what? If the ratio of the inner diameter of the cylinder to its wall thickness is less than or equal to 20, then the cylinder is called as what? Thick cylinder. Okay, and the example of thick cylinder is what? Hydraulic cylinder, high pressure pipes, gun barrel and reactors. Okay, this is nothing but the basic difference between the thin and thick cylinder. It is denoted by using what? This ratio, inner diameter to its wall thickness. Next point that we are going to see is stresses in thin cylinder. Okay, generally there are three stresses in thin cylinder. The first one is circumferential or tangential or hoop stress. Okay, there are having three names but the meaning remains same. It is denoted by letter sigma t. Second type of stress is longitudinal stress, and the third type of stress is radial stress. Okay, generally the radial stress is very small in thin cylinder, that's why it is neglected. So there are only two stresses in thin cylinder, one is circumferential, tangential or hook stress, and second one is the longitudinal stress. Okay, the first type of stress is denoted by letter sigma t. This t indicate for tangential stress, and the formula to find out this tangential stress is pi into di divided by 2 times t. Okay, similarly in longitudinal stress it is denoted by letter sigma L. This L is nothing but what? Longitudinal stress. For that formula is pi into di divided by 4 times t. Okay, here what does that mean? Pi, this I suffix letter indicate internal pressure, okay, and its unit is Newton per mm square. Next is di is nothing but inner diameter of the cylinder, and this T is nothing but thickness of cylinder wall. Okay, next point that we are going to see is thickness of thin cylinder. How we are going to calculate the thickness of thin cylinder if they are going to ask in the numerical? In that case, this T is nothing but pi into di divided by 2 times sigma all. Okay, here sigma all is nothing but what? Allowable tensile stress for cylinder, and its value is Newton per mm square. Okay, in some cases in numericals, sometimes they are going to give the direct value of sigma all. Okay, but in some cases they are going to mention the value of S of ut, that is ultimate tensile strength. So in that case, how you are going to find out this value of sigma all? In that case, sigma all is nothing but S of ut divided by factor of safety. Okay, so in that case, S of ut they are going to mention, also the factor of safety is also mentioned. So from that you can calculate the value of sigma all. Next problem is what? In generally, cylinder we cannot manufacture in a single piece. Okay, it means there are some different parts. We are going to join together these parts, and after that we are going to make the cylinder. So it means what? There are different parts. Okay, so for that different part, the efficiency will be different. It means there are some joints. So in that case, when we are going to consider these different joints, in that case again the thickness of the cylinder is going to vary. So in that case, the T will be T is equal to Pi into Di divided by 2 times sigma all. This formula remains same, multiplied by Ni. Okay, I am saying multiplied by NL. Okay, NL. Sorry, it's NL. Okay, this NL is nothing but what? Efficiency of longitudinal joint. Okay, sometimes in the numerical they are going to mention two efficiency. The first one is efficiency of longitudinal joint, and second is efficiency of circumferential joint. So in that case, only you have to consider the efficiency of longitudinal joint. Okay, don't take the average and divide by 2. Okay, don't do these things. So just take efficiency of longitudinal joint. Okay, this is about the thickness of thin cylinder. And next part is what? Stresses in thin spherical vessel. Okay, in the last point we have seen stresses in thin cylinder. Okay, but if the shape of this cylinder or vessel is in spherical shape, so what are the different stresses induced in that we are going to find out. So in that case, there is only one stress which is induced, which is called as circumferential or tangential or hoop stress. Again, it is denoted by same letter, that is sigma t, but the formula is different, that is pi into di divided by 4 times t. Again, here pi is nothing but internal pressure in Newton per mm square, di is nothing but internal diameter, and t is nothing but the thickness. Okay, and after that, thickness of spherical vessel, it is denoted by t. This can be found out by using pi into di divided by 4 times sigma all. Okay, after that, again, if you want to consider the efficiency of joint, as I said, this vessel is going to manufacture by using joining the different parts. Okay, so if you want to consider the efficiency of the joint, so in that case, T will be what? Pi into di divided by 4 times sigma all. This term remain same. Okay, this term is not going to change into NC. Here NC is nothing but what? Efficiency of joint. Okay, the last case, thickness of thin cylinder, we are going to take this NL, efficiency of longitudinal joint, but in spherical vessel we are going to take NC, that is efficiency of joint. The last point is, if they are going to ask you the storage capacity of the spherical vessel, so in that case the formula will be what? V is equal to pi by 6 into di cube. This is the unit of what? Volume. So this V is nothing but the volume, and its unit is mm cube. Okay, this is all about the cylinder. What are the different example of cylinder? What are the different types of cylinder? What is meant by thin cylinder, thick cylinder? How you are going to denote this thin and thick cylinder? What is the difference between these two? What are the example of this? What are the different stresses induced in the thin cylinder? And what are the different stresses in thin spherical vessel? These are all the points that we have seen in the first video. Okay, in the next video we are going to solve the different numericals which are based on thin cylinder and thin spherical vessel. Okay, thank you so much guys, have a nice day.